Any day now, ZWO is expected to release the long-awaited for update to their Seestar app, which allows us to mount and operate the Seestar in the equatorial mode. This opens up a whole new world of opportunities for us, including much longer exposures and far fewer drop frames. Hi, I'm Curtis, and in this video, I'm going to go through the advantages of operating in the equatorial mode as compared to the Alt-Az mode. I'm going to show you several different hardware options for mounting and operating the Seestar in EQ mode. And I'm going to show you how to do a pre-alignment during the daytime so that when the stars come out at night, you can quickly fine-tune the alignment and get started taking images in the EQ mode right away. Now, I should point out that this is not a sponsored video. All of the equipment you see in this video is my own equipment, which I purchased myself. I will put links to all of those down below this video where it says more. Just tap on that and it will expand and you will see those links, which will help make it easier for you to find the equipment I discuss. Also, if you learned something from this video, please like the video. That makes it much easier for other people to find. And you might also want to subscribe to the video so that you can be alerted when I post other videos like this in the future. The Seestar has shown itself to be a remarkably easy to use smart telescope, producing some amazing images of deep sky objects. But because it's designed with an Alt-Az mount, that greatly limits the length of the exposure to 30 seconds or less because of field rotation. And it also means that we can't track objects as they get close to and pass through the zenith because of that field rotation issue. Now that we can operate the Seestar in EQ mode, we're no longer going to have to limit ourselves to exposures of 30 seconds or less because of field rotation. We can do much longer exposures, which will be limited only by the precision of our polar alignment and the mechanical capability of the Seestar mount itself. In addition, we'll also be able to image objects all the way up to 90 degrees. And in fact, we can track objects all the way through the zenith. With a good alignment in the EQ mode, we'll get much less star trailing. So we'll have much better stacking efficiency rates. And for those of you who do post-processing of the individual images, in astrophotography software like Serial or PixInsight, you'll have a lot less frames to deal with if you can, now that you can take longer exposures instead of taking many short exposures to come up to the same equivalent total exposure time. And finally, working in the mosaic mode will be a lot simpler, and you'll see a dramatic increase in stacking efficiency there, meaning that we'll be able to do these mosaics in much shorter times than we have been working in the Alt-Az mode. So the first thing you might want to consider when operating in the EQ mode is upgrading to a taller tripod than the original tripod that comes with the Seestar. And the main reason for that is that because this is so short, even with the legs extended, with the Seestar mounted at an angle, this thing becomes top heavy and potentially could wobble and tip over. And you don't want that to happen, obviously. So what I have here is the Skywatcher AZ GTI tripod, which you can get for about $85. And as I said, I'll put links to this and the other tripods I talk about down below. It is pretty sturdy. I'm happy with it. It gets you up off the ground about 41 inches, which also has the added advantage of giving you enough height to clear any obstructions you may have where you do your observing. Like in my case, I have to clear the house when looking in the south, so it helps to get this up off the ground. Now, I like this tripod. It's a nice tripod and it's not expensive. Now, not only is this tripod low cost at $85, but it's fairly lightweight and fairly compact as well. If instead you want to upgrade to a large carbon fiber tripod, you can get the ZWO carbon fiber tripod, which you see here. This is the one they normally pair with their AM5 and AM3 mounts. You can get it for $350, and it will bring you up to a height of about 31 inches above ground. And if you want another carbon fiber option, you can get the cheaper one from Apertura for about $250, which you see here. Now, any of the three tripods I mentioned, plus the host of many other tripods out there, will work quite well. But there's a couple of things that you can do to improve the stability. So if you're set up on grass or dirt like I am, especially if it's a little bit moist, you're going to want to make sure that the tripod legs don't shift and sink into the ground over time. That'll throw your alignment off. One way to prevent that from happening is to use these anti-vibration pads, which not only help provide a larger footing area for the tripod legs, but also dampen out any vibrations of people walking nearby. Now, another cheaper way of doing it, which I use with my larger scopes and I can use with this tripod as well, is just get yourself 3 pieces of wood, cut them down to a small size. You can even put a divot in the middle so the tip of the tripod fits in there. Set this on the ground and that spreads the weight out so it won't sink into the ground. Another thing you should do is put some sort of weight onto the tripod itself. So in this case with the AZ GTI tripod, I have a counterweight from one of my other telescopes, which I'm putting on the accessory tray. You can do the same in the bag on the ZWO carbon fiber. Just put some rocks or some sand in there and weight it down. That provides more stability as well. And the final tip to get more stability when you're mounted in the EQ mode is to make sure that the ZWO itself is hanging out over one of the tripod legs. Where I have it now, it's hanging over the back. That's not the best place to do it. If I loosen the mounting bolt here on the Skywatcher and then tighten it, I can set this up wherever I like it very easily. And now it's leaning over the tripod leg itself, which provides the maximum stability against this thing wanting to move or tip slightly. And as you can see, you also want to mount the Seestar so the power button is facing up. When it comes to mounting the Seestar in the equatorial mode, we have 3 different options. Of course, we have the equatorial wedge, which most people know about, and I'll discuss this Skywatcher AZ GTI wedge. We also have the option of using a camera pan head, which attaches to the top of the tripod. And finally, if you already own an equatorial mount, you can simply get one of these inexpensive adapters and attach the Seestar to your existing equatorial mount. Now I'll go through all 3 of these options in detail. If you already have an EQ mount like this CG mount from Celestron that I have here, the cheapest option is to use that mount and get yourself one of these adapters. This is $15. Again, I'll put a link down below, and you simply thread it onto the bottom of the Seestar, and then you can clamp it into any Vixen style saddle. And of course, we're not going to use the motors on this CG5 or whichever mount you have. We'll use the motors on the Seestar. This is only here so we can turn this from an alt-az to an equatorial mounted telescope. The Skywatcher Star Adventurer Latitude wedge is the cheapest wedge I can find, and it actually works quite well with the Seestar. You can find the Skywatcher wedge for between $80 and $85. I'll put links to some of those down below the video. And with its 3/8 inch threaded hole in the bottom, it easily attaches to any tripod with a 3/8 inch bolt. And it simply just screws onto the bottom here. You can align it wherever you want, and then it becomes part of the tripod. Now let's take a closer look at the wedge. First of all, it has an altitude axis in this direction here so that you can adjust the angle of the attachment point. And you first loosen the locking knob, then you use this knob to set the angle. Now, there's a graduated scale there in 2/10 of a degree. I'm at a little over 37 degrees, so I can set it pretty close to that and lock it into position, and then we will fine tune it when we do the actual polar alignment. Now, there's also, on the other side, there are a set of push-pull knobs, which allow us to loosen one and tighten the other to rotate the telescope in azimuth during the polar alignment. Now, tip, make sure when you start that you have equal amounts of thread on both sides so that you have adjustment both east and west of the North Celestial Pole. Because when we do our rough alignment to the pole, we're most certainly going to be off a little bit in one direction or the other. And since we don't know ahead of time whether it will be east or west, you want to be able to make adjustment in either direction. Now, there's also a shoe that you attach with this 3/8 inch thread to the bottom of the Seestar. I'll show you that. And then there's a safety stop here. And so the safety stop goes on this side so that when we mount the Seestar on there, it won't slide off. And then this locking knob locks it in place, but this particular locking knob has too short of a rod, threaded rod, so that it will interfere with the base of the Seestar. So we have to remove this, and it turns out this is just an M8 hole. So I happen to have this long bolt which I can thread in there, and it doesn't stick up. This is actually much longer than it needs to be, but then I can tighten it down, and when I attach the Seestar, this will be locked in place. So just find yourself an M8 bolt, then you're in great shape. After I shot the previous video segment, I was able to find this M8 threaded rod with a handle on the end. The thread is 50 millimeters in length, and the handle can be adjusted in any direction that you want it to be in. And at 50 millimeters of thread, this just clears. I think a 40 millimeter would be just too close. If you prefer that over the bolt I showed you in the previous video, I'll put a link down below the video so you can find this easily. But it might be nice to have the handle, and that way you don't need to carry around an Allen wrench in order to tighten the bolt. Now to mount the Seestar on the wedge, we're going to have to attach the adapter to the bottom of the Seestar first. Now, a couple of things to point out. There is this threaded stop, which is the safety stop, so that it will stop the Seestar from sliding out. The only problem is if you thread it all the way in, it sticks out substantially and it will interfere with the base of the Seestar. So when this thing rotates, it'll actually provide some friction and it'll scrape out a circle and it'll put it a little bit off level. So we don't want that to happen. So I can think of a number of things you could do. You could go to the hardware store and find a similar threaded screw that is shorter. You could cut this one down, could put some washers in there, or what I'm going to do is thread it into the point where I want it to stop, and I'm going to use some thread locker on it. Then I'm going to want to attach the mounting adapter, thread it on to the screw hole on the bottom of the Seestar, and I'm going to want the long axis of the adapter to be perpendicular to where it says Seestar, and I'm going to want the safety stop to be at the bottom. And we'll just finger tighten that in there, and then I'll use the Allen wrench to make sure it's secure and tight. And it doesn't have to be perfectly square. It's not going to make a difference. So it's in there, and now we can mount it on the wedge and then tighten our bolt, tighten our replacement bolt, whatever you find at the hardware store to replace that knob. Now we're on there tight and secure, and we're good to go to the next stage, which will be the rough puller alignment. So as I said, one of the options for mounting the Seestar in EQ mode is one of these tilt pan heads. So we went out and purchased 3 different ones so you can get an idea of the differences among them and what's available out there. So this one is from Avila. This cost $30, around $30. This is newer. That was $40. And this is K&F, and that was $50, right in those price ranges. And you see, this is the biggest one of the 3. This has an 11-pound capacity. These two, 6.6-pound capacity. The Seestar weighs in at 5.5 pounds, so these will handle the Seestar. This will have more margin. You can see the handle's bigger on this one. This has the smallest handle. The base on these are different. So this has the smallest base. This has the largest base, which can help with stability. But putting these on the tripod, I haven't seen a big difference in the stability because of the smaller base. The design of these things is basically the same from one to the other. So I'm going to use this bigger one. It's easier to see, and I'll go through the features of it. I'll mount it on the tripod, and we'll go from there. The first thing to note is that all of the pan heads can be mounted directly to the bolt sticking up in the tripod. However, these pan heads are shipped with a 3/8 inch to 1/4 adapter threaded in the bottom. You're going to want to take that out so that you have the 3/8 inch opening here. And on the top with the adapter, it comes with a 1/4 inch. And you're going to use this 1/4 to 3/8 so that this will fit into the base of the Seestar. So you're just going to remove it here and use it up here. The second thing to note is that all three of these mount on here just fine, but with the one from Newer, I had to use a washer so that I could get this threaded on tight because the bolt bottomed out in the hole on the Newer. But that's not a problem if you stick a washer on there. Okay, so we just bolt that on there and snug it down. And so let's just go through the basic features. So this is the altitude locking knob. And so this moves up and down. And these are all fluid filled. So the motion here is nice and smooth. I think this will work really well when you're trying to use the Seestar app to guide this to the right altitude based on the feedback from the Seestar app itself. And then you can lock in place wherever you are. Now there's a locking knob on the side here. And as I have this configured, the locking knob just comes in contact with this metal ring on the tripod. I could put in a washer below to raise it up a little bit, but I can still maneuver this. This allows us to swing this in azimuth, and as you can see, there's graduated scale here, and that's present on all three of these. So they all have this locking knob, and then they also have a little bubble level that you can use. Now it's not extremely imperative to be level when you're working in the EQ mode, but it never hurts to start off level. The other thing is you have this handle here, and the handle can be locked into place in a number of different positions. You can actually reverse it so it's locked in the up position. You can loosen this, slide it out, and lock it in a lower position like that. And so you're just going to want this to be out of the way of the base of the Seestar so that when it rotates, it doesn't hit the handle. And you're also going to want this to be in a position where you can rotate this to the latitude that you want. You don't want it crashing into the legs on the tripod. So remember, we're going to want to have the Seestar tilted so it's hanging over one of the tripod legs. Now let me bring this up. And here's the locking knob for the adapter plate. And now let me lock this azimuth. And when you unlock this, this does not slide in because it has two stops. And these are grooved so that it doesn't slide out either way, but it tilts in and then it locks in place. And so we're going to need to take this out. And as I said, we are going to put the 1/4 to 3/8 inch adapter on here to get this to lock into the Seestar. But actually what I found is you want to put this into the Seestar first. Put the adapter into the base of the Seestar. That way you can more freely angle this so that you get the Seestar mounted with the power button facing up. So as I said, I put the 3/8 to 1/4 adapter in first into the Seestar, and then I threaded this adapter plate on so that I could get it lined up so I can have the power button facing up. And then we're just going to tilt this in place. You're going to hold on to it so you don't lose it, and then tighten it down. Now it's tight. Let's make sure this knob is tight. Make sure that knob is tight. And so there's a little wiggle there, but that wiggle I notice is in the base of the Seestar mounting itself. And I don't think this thing is going to cause any problem. And I find this to be about the same on all three models of pan heads. Now the important question is, what latitudes can you go to with this mounting mechanism? So if we put the load over the tripod leg, and if I measure this carefully with a level, I can see it goes to about 30 degrees where the Seestar is free to rotate and won't bang into the leg of the tripod. And I have the handle adjusted so it's out of the way and I can go down as low as possible. so about 30 degrees latitude. The other two, it seems to be more like 35 degrees latitude. But if you want to work at a latitude lower than that, you're going to have to boost this up above the tripod leg. Now, keep in mind, things may be different for different tripods, but I don't think they'll be dramatically different. They should be about the same, but maybe not exactly the same. So let me show you an option to raise this up a bit so we can go to an even lower latitude for those folks that are down closer to the equator. Now, as I said, if you need to go into a lower latitude, you need a spacer. And if you happen to have one of these 3-point levelers, it becomes a convenient thing to use as a spacer. As I said before, you don't really need to level this thing, but it acts as a nice solid base to space this. And this now can go down to about 25 degrees latitude without banging into anything. And actually, we're limited in latitude by how far the actual pan head itself can tilt in that direction. So that's about 25 degrees latitude. If you want to go further, you can go around to the other side. And the nice thing about having this spacer is this doesn't interfere anymore. You can go to the other side where the weight will now be out in the open. And let's rotate this Seestar base. And now we can go down, 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 down. And we're almost vertical there. So you can really adjust this to very low latitudes. Now that we have the Seestar mounted in equatorial mode, and it doesn't matter whether you use the wedge, the pan tilt head, or your own equatorial mount, we can take advantage of the daylight to pre-align the telescope to true north. Now, you don't actually have to do this. You could do this all at night, but I think it's more convenient to do this during the day. That way at night in the dark, you're just doing the final fine-tuning of the alignment. Now, you can do that using a standard good old-fashioned compass like I have here, but there's two things you need to consider. First of all, if you have any steel, ferrous metal around, you definitely don't want to get the compass close to that. I wouldn't want to set it on this tripod base with the steel counterweight there, because any ferrous metal will screw up the magnetic field and you'll get a false reading. So stand back behind your tripod in the Seestar and find the direction of magnetic north. Now, the second thing to take into consideration is that magnetic north is most likely not going to be your true north unless you're at the North Pole. And that's tied up into something called magnetic declination. And magnetic declination is the offset between where the compass on a magnet points versus where true north actually is. So where I live, the magnetic declination is 12.9 degrees east, which means the compass will point to a place that is 12.9 degrees east of true north. So I would have to line up 12.9 degrees further to the west. So take that into account when using a compass to do your alignment. And you can look up the magnetic declination online. I'll show you in a moment a place that you can do that. Now, there is another way, and most phones, like this iPhone, will have a compass app. And this compass app will demonstrate which direction is north. And if you go into the settings for this app, you can put in the magnetic declination like I have for my home. And now where it says 0 degrees or 360, this is pointing to true north. It takes into account the magnetic declination. So you can use the compass app on your phone. Just make sure you either have installed the magnetic declination or you take that into account when you find the direction of magnetic north. So if, like me, you're 12.9 degrees east of true north, you subtract 12.9 degrees from your reading and you move to the west by 12.9 degrees. If you're west, if your magnetic declination is some number of degrees to the west, you will offset those number of degrees to the east of where magnetic north is. So you can find the magnetic declination of any location by going to this site, ngdc.noaa.gov. And if you're going out in the field and you don't have access to internet, you can just find out what it is, take that with you and make the adjustment in the field. If you're at home, like I am, it can connect to the internet And then you can just move this around and you see the N inside the green triangle. That's true north. And then inside that, in the yellow ring, you see the M inside the orange triangle. That's magnetic north. And down below, you see my declination, 12.8 degrees. I said 12.9. All right, sue me, 12.8 degrees. So then you would just find true north, and then I would adjust the position of this. In this case, I can simply pick this up, rotate it a little bit, and be in that direction. Remember what I said before, you want to make sure the azimuth screws are such that you have about equal travel in either direction, so when you're fine-tuning it, you're not at the end of one axis and don't have any more travel left. So now we can leave it at that. We're pre-aligned, and we'll fine-tune it when we get to night, which of course we're going to have the actual app itself available to do that, and I'll make another video showing you exactly how to go through that step by step once they release the app with the EQ mode. So that's all we can do to be ready when ZWO releases the app with the EQ mode. We've got our hardware, we've got our tips for setup and pre-alignment, and once they release the app, I'll create another video and we'll walk through step by step to do the fine-tuning at night, and we'll actually demonstrate image capture in the equatorial mode with the Seestar. So once again, I hope you enjoyed this video. I hope you learned something from it. Please like it if you haven't already. Don't forget to subscribe. And don't forget, you can support this channel at no extra cost to you by using the links I posted down below this video for your purchases. So until next time, clear skies.